Okay, so looking at part D and part E. Let f of x be the function that represents the square of the distance. So we're looking at the square of the distance at point P. So find the times at which f of x, so that's the square of the distance. And this part is asking about the distance, not the square of the distance. So part E is asking about the distances only, and part D is asking about f of x, which is the square of them. So I'd expect that the distances would be, so that, let's say the distance of point P from the origin will be the square root of 4 cos of whatever the angle is plus 70 squared plus 4 sine of that angle plus 6 squared. And for part 1, we are then squaring it for that part D. For part E, we're looking for the maximum minimum distance. So over here, I've got, this is exactly the square root of, so if I was to open a graphing window, do my window from 0 to 65 because the period is 60. So, okay, if I pick this up, well, that's my answer. Pick it up, drag and drop. Analysis G-solve minimum is 66.25. So minimum 66.3 meters. And analysis G-solve max, that is 74.25, so 74.3 for the max, because that was to do with distance. Now, for the next part, I need to take this and then square it, which gives me this expression. And I'm interested in the values when it becomes either a minimum or a maximum. So I need the derivative of f of x and set it equal to 0, because that will give me when it is a minimum or a maximum, a minimum or a maximum. But remember, this isn't the same as the distance. It's the square of the distance. So I squared my expression there. And with this answer, I'm going to take the derivative, set it equal to 0, and in this case solve for x. And I get that, which tells me if I use the term, if I take this answer and put it into a new line, and I get rid of all of that and just use the term n for my constant, I have c, which is 30, and c, which is 30, and I have d, which is 3, and I have c, which is 30 plus 5. So c is 30 and d is 3. And I would write this here. I'd use t instead of x. So the trick or the difficulty about the back part of this question was they weren't using the same things. This was using the square of the distance, whereas in E's case, it was just using the distance.